All right, dude, we are live. What's up, guys? This is Dem Keys, and today I'm gonna be carrying on learning about modules in Rust. I want to see this little distraction that I've had that led me to, restart learning modules, restart learning, or well, this little distraction that led me to start looking deeper into modules. I kind of want to see this distraction all the way to the end. So yeah, we're gonna finish learning about modules. There's a bunch of use cases for me. Also, I am probably also gonna start looking into using WebSockets, not as a replacement to sockets, but as well. I mean, it's not like, how do I say this? Not as a replacement, but as an extra option. If I'm ever in a situation where I don't want to go through the headache of setting up a server, or rather building, I should say, not setting up. If I'm in a situation where I don't want to go through the headache of building a server and building a client and then setting up their whole communication architecture and all that, I can just go with WebSockets, because WebSockets, or is it WebSocket? I think WebSocket, right? Like, what's the exact? This is a dumb thing to focus on, but like, I wanna get it right. Just give me a second. Let me scroll all the way back. WebSocket. Okay. So, why was I talking about WebSocket? Fuck! I just lost my train of thought. Where were we? WebSockets. WebSockets allow communication, right? A lot of times, when you see WebSocket support mentioned somewhere, the idea is that they provide you with an implementation, their own implementation of either a WebSocket server or a WebSocket client, or both, and then you can set up whatever you want to set up using that. So the idea is that they give you the tools. They create a WebSocket server that implements the WebSocket protocol, and they create a client that implements the WebSocket protocol. Or at the very least, they'll create a library that allows you to instantiate these kinds of things. So I feel like it's going to be useful because I've seen WebSockets mentioned now multiple times in various things that I've been doing. Some very good examples. A very recent one. Well, some I can't really talk about, but the ones that I can talk about are Godot. I've definitely seen WebSocket mentioned there. In fact, they have their own implementation of WebSocket for you, and you can like just use that. So that makes things so much easier, doesn't it? Like, imagine I have to like, okay, let's say I want to communicate. I want to do IPC between inter-process communication between two Godot clients, right? One can be the server, the other can be the client, and I can easily do communication between them. This is great for like simple messaging, because the idea with I mean, I haven't studied the website. You know what? I could make a stream out of that. Just one stream where I implement. I don't implement. I use other libraries and tools that help me implement a WebSocket server and a WebSocket client. I believe there is one for Rust as well. Pretty sure there's one for C#. I've seen the C# one. Hold on. WebSocket C#. WebSocket C# GitHub. Okay, so there's this one by someone named Star or STA. I don't know. I don't know if I'm saying that right. But I've seen this this library being used in a couple of places. I believe Vinyan also uses it. So I want to look into using this, but this is on the C# side. I think I'm pretty sure someone has made a Rust implementation as well. There is one. I'm gonna look for. Okay, so here's a crate. I found a crate. Let's see if we can find the code. Okay, source is not helping me. Where can I find... Okay, let's... I just realized I'm doing this on a different system. You guys cannot see what I'm doing. You have no idea what I'm talking about. Okay, hold on. I'm just Googling real quick and I'm gonna... what crate to use to make a WebSocket client? Okay, this is a question from 2023. As a general tip, you should always check GitHub. Check the GitHub repo of a crate. Often repos have more examples. Okay, so there's something called Tungstenite by someone named SnapView. So I'm just opening that up real quick. Lightweight stream-based WebSocket implementation for Rust. Okay, hell yeah. And this seems to be currently being maintained. Right, cool. So we have one for Rust as well. There's one for C# as well. Actually, there's a couple for C#, not just one. But I usually aim to go for... this is gonna sound weird, but like I usually aim to go for the one that has the highest number of stars on GitHub. It's not just about the number, at least when it comes to GitHub. Like the thing having a higher number of stars, it doesn't just tell me that, oh, this thing is popular. It tells me this thing is popular because people are using it. It is widely being used. So first of all, the thing has to have, you know, a decent number of stars. And then the next is it has to be something that's actively in development, because I don't want to use something that's old, because there's chances that, you know, stuff might break in it. And if the thing is actively being maintained, then chances of things breaking are much lesser, because there's a decent chance that if there was an update to something, the underlying technology that this... How do I explain what I'm trying to explain? Basically, if there was something that broke, someone else must have already found it and reported it, and somebody on the team who's maintaining this thing must have already fixed it. That's the great thing about, you know, a repo that's got a bunch of people contributing to it and a bunch of people using it, and therefore, you know, a bunch of stars and stuff. That's why I kind of prefer to go for the more widely used libraries. There's also the fact that because it's more widely used, there's higher chances of me being able to find like documentation on it and getting any kind of help if I need, or even just googling something about that framework or that library or whatever. There's a chance that somebody else must have already had that question that I have, and so someone else must have already answered it for them. So I'll just be able to Google it and find the answer. Okay, all that being said, dude, let's jump into... Wrong keyboard. Hold on. Okay. Let's jump back into this. So I was reading Are we done here? I'm not sure. Yeah, I think I was done on this page. I was on this page. Paths for referring to an item in the module tree. So it was explaining that there are two ways that you can represent a path. One is an absolute path. I guess let's carry on reading from here. Hold on, let me hydrate real quick and then I can start talking. All right, you know what? We can start reading from the top. To show Rust, just a second. Okay. To show Rust where to find an item in a module tree, we use a path in the same way we use a path when navigating a file system. To call a function, we need to know its path. That makes sense. A path can take two forms. An absolute path is the full path starting from the crate root. For code from an external crate, the absolute path begins with the crate name. And for code from the current crate, it starts with the literal crate. All right, that's good to know. Because in the future, I do want to practice making my own crates as well. My own like libraries that I can export. Which, by the way, I need to look into fucking what is that? Unit tests. Because if I'm gonna be making libraries, I think the only way that I can test it is through those unit tests. I could be wrong. You know what? Let me Google that. Give me a second. Rust, how to run library. I know you can't run a library, but like I have to Google dumb shit so I can find answers that I'm looking for. To link a crate to this new library, use Rust C's extern flag. Okay, so that's the documentation for using. Oh, this is part of Rust by example, using a library. Where is this from? Like, where was that mentioned? Under crate. Creating a library. So this was pretty short. It didn't really go into too much detail. At some point in time, I would like to go into the more advanced features of Rust. Stuff like, at least, I mean, for me right now, it's advanced features in Rust, like implementing my own iterators and closures and stuff. I think I've looked into closures. I don't remember exactly. But like for the time being, I'm gonna have to start from the basics, and with time, I'll learn all of the other stuff. Okay, customizing builds, publishing a crate to crate.io, crates.io, smart pointers. There's another topic that I definitely need to look into that. Threading and async, it's just gonna have to wait until later. Threading is definitely gonna have to wait until later. Async, I need to look into that. Because whatever I'm doing, I don't want it to be blocking the main thread. So yeah, I'm definitely going to be looking into async. Which, I mean, now that I'm saying this, I'm wondering like, okay, I thought this was just going to be a distraction that was going to last for a short period of time. Actually, maybe I should just keep this distraction for a short period of time. And then later on, I'll learn the extra stuff as I need to. Fuck, dude, I need to implement something in Rust so that I get a better idea of what I'm doing. I need to implement something. I need to build a project in Rust so that I get an idea of what I'm doing. I'm gonna have to come up with ideas for things that I can do with a console project. The best idea I can think of right now, I mean, there's a bunch of things that I can do with like a bare bones console project. But what I had in mind was using the Windows crate. So I can like interface with Win32, the Win32 API, and see what stuff I can do. Because like that would be a good way for me to learn how the Win32 API works. Because dude, there's a lot going on there. Like, believe me when I say there is a lot of shit going on there. There's a lot to study, is what I mean. I there's a lot of shit going on there. There's a lot that you can study. There's various components to how there's various components working at any given time. There's a lot that you can learn in terms of like how messages are passed from one point to another. What exactly happens when, for example, you send an input. You click your mouse button and something happens in the window. There's a lot that you can learn about. So this thing about like input events and all. Apparently, there's like a message queue system. And there's something that processes each of these messages. You can tap into a lot of these things, and you can like read messages. You can even send your own messages and a bunch of things like that. So there's a lot that you can learn with if you. This is one of the reasons why I'm aiming towards the Win32 API, the Windows crate, because like I'm gonna be able to do. With that, I'm going to be able to practice Rust while also learning about the Win32 API. And it's great because I don't have to deal with fucking p-invoke bullshit anymore. I can I mean, to be fair, even on the C# side, they did create a project. It was called... fuck, I forgot what it was called, dude. But it was based on, like, it was using the Win32 metadata thing. I'm blanking on what the fucking name was. Hold on. It was called CS something. CS p-invoke? Hold on. P-invoke CS. P-invoke.cs. Okay. Nope. Not what I'm looking for. What was it called? CS Win32, I think? CS Win32. Yeah, that's what it's called. CS Win32. It's a p-invoke source generator. Basically, the idea is, or at least back when I had messed around with this, which was probably a year back. I don't know, a couple months back at the very least. The last that I had messed around with it, the idea was you install this library, and then there's a file. You can create a file where you list all of the methods that you need, all of the Win32 API calls that you need, or all the Win32 API functions that you need. I don't remember if you can also list the types that are needed, or if the types are already just present there for you. But yeah, the functions, you need to list them. And then based on the functions that you have listed, these have to be like actual Win32 API API functions. So the functions that you list, based on the metadata that this source generator has, it's gonna create the functions for you. It's gonna generate the source code for those functions. So that way you don't have to deal with the whole p-invoke bullshit. You can just, when I say p-invoke bullshit, it sounds so negative, but it's just that it can be very frustrating for a lot of people, having to deal with p-invoke stuff. So yeah, that way you don't have to deal with p-invoke stuff. All you have to do is then call the methods, because the methods are going to be created for you through the source generator. And that same technology is also being used in the Windows crate. I believe it's called the was it Win32 metadata or Windows metadata? Give me a second. Win32 metadata. Yeah, it's Win32 metadata. So the idea with that is that it basically through this, you're able to get like a description of what the API is supposed to look like. And then based on that description, other source generators can like generate the methods that are needed. It's a lot more complicated than what I just said, but like this is the best, simplest understanding that I can give. And to be honest, I myself don't fully understand how the thing works, but like based on my understanding, that's kind of what's happening. Like it allows you, or it provides you with the details of the API that you are trying to generate code for, and then you can write a source generator that gives you that generates methods based on the data that's given. Okay, that being said, I need to come up with some ideas for stuff that I can do. There's actually a lot that I can do in terms of like Win32 stuff. Like if I'm using the Windows script, there's a lot that I can do with the Win32 API. I can also do audio stuff with the Win32 API. Or, well, I don't know if it still counts as a Win32 API. Hold on. We can like explore this on stream. Just give me a second. Right, Win32 API. Programming reference for Win32 API. Hopefully this gives a bunch of topics that I can pick stuff out of. Yeah, okay, I think this is it. This is it. So we're gonna transition back. Also, something else that I can do is I can disable this and I can enable this and show it like this. That's much better. Right, so temporarily you guys can also see like in full screen. So all of these, like this is the Win32 API programming reference, and here you have like a bunch of the topics, right? There's UI stuff, there's graphics stuff, which I definitely want to look into the graphics stuff. Also, I just noticed DirectML is part of this. I didn't realize that. Okay. Wait, what all does this provide? Okay, we have interfaces, functions. Let's look at functions. Bind input. Binds a buffer as a persistent... Wait, when did this happen, dude? When did DirectML become part of fucking Win32 API? Because I remember reading about ML.NET. I don't know if that was like internally using DirectML. I need to look into DirectML, dude. Actually, what I should look into is DirectML good? as silly as that may sound. DirectML is a high-performance, hardware-accelerated DirectX 12 library for machine learning. So, hardware-accelerated, meaning, I'm assuming it means that this allows you to use the GPU to a certain extent. Compile operator. Compiles an operator into an object that can be dispatched to the GPU. Yeah, dude. I should look into this. Okay. Now, next thing, let me look up DirectML versus... Okay, there's one suggestion. DirectML versus CUDA. I'm guessing CUDA would be better. I could be wrong, but I think CUDA would be like if I had to guess, I would say CUDA would be better. I could be wrong, but like the reason I think CUDA would be better is because NVIDIA is actually like putting effort into a lot of AI related stuff, and CUDA is it's most definitely being used for that. Among a lot of other use cases as well, it is definitely being used for AI stuff. So NVIDIA is like they're putting a lot of effort into this. Direct ML, Microsoft might be doing the direct ML thing, but like I don't know if they're putting as much focus into this as NVIDIA is putting into CUDA. That being said, there is a post here that says CUDA being tied directly to NVIDIA makes it more limiting. That is very true. In order to use CUDA, at least like directly, you do need an NVIDIA GPU because CUDA is NVIDIA's proprietary technology. There might be like tools that let you translate stuff. I'm not sure to what extent they work, how flexible they are. I've never tried that. I've never tried running CUDA code on like an AMD GPU, for example. But okay, so what I was really trying to Google here was DirectML versus something like TensorFlow or PyTorch or something, but like CUDA came up, so I looked at CUDA. Now somebody asked this question like 3 or 4 months ago. So it's not even like that far back, which is a good thing. I'm getting a more recent answer. I wonder if this is, I mean, this is part of the Win32 API, isn't it? I would say so. So by that logic, would this be available? This is very good news for me, because this means that if I wanted to do some ML shit using Rust, I could. Though, I mean, there's definitely much better solutions. I can confidently say that there's going to be much better solutions. Solutions, not just one. There's a list that mentions a bunch of projects that are some were in the works, some are in the works. So like I'm pretty sure there's going to be okay. Okay, so this question that was asked had to do with something else. Now, okay, so I kind of branched out with what I was saying about like which one is better, DirectML or CUDA. But like I don't think comparing the two would necessarily be fair. But like I mean, like I was saying, if I had to compare them, then I would say CUDA probably does a better job. But it's also limited because CUDA is NVIDIA's proprietary technology. But also because it's their proprietary technology, they kind of put a lot of effort into building it, and like they're doing a lot of like I said before, they're doing a lot of AI and ML related stuff. So I can, for some reason, I can just assume that NVIDIA is putting a lot of effort into this and CUDA is going to be faster. That being said, that doesn't mean that DirectML is going to be bad or worse. It just means that it might not be as fast as CUDA. I could be completely wrong about this as well. It could be incredibly fast. It could be, who knows, just as fast as CUDA, if not faster. But the thing is, I feel like I'm comparing two different things here. Because DirectML, I need to figure out if DirectML is... because like when you compare DirectML and CUDA, CUDA is more about CUDA is more about like writing compute code that can be executed on the GPU. Direct ML seems more like a framework for doing ML related things. So I should initially what I was trying to compare before the Google search suggestion kind of made my mind branch out. What I was initially going to Google was direct ML versus TensorFlow or PyTorch. I wasn't going to Google direct ML versus CUDA, but then that suggestion showed up. Now I need to figure out, hold on. There might be, let's go all the way to the bottom. Is there some suggestions? There's no suggestions here. So I'm going to Google direct ML because we are looking at an API reference. Okay, direct ML is a high performance hardware accelerated DirectX 12 library for machine learning. Okay, so this is then more comparable to PyTorch and TensorFlow than it is to CUDA because it's not specifically meant for computing. It's more of like a, it's one of those things where like I wonder if this if I can make neural networks with this. Okay. Neural performs a one-layer simple recurrent neural network function on the input. Okay, how many? Okay, there's only one match there. Okay, all right. There's an ad playing, so I'm gonna hydrate. Give me a second. I'll hydrate while the ad finishes. All right, welcome back. So, I am looking for. Okay, let's look at Anne. That's not helping. Okay, what about convolutional neural network? Performs an ROI align operation as described in the Mark R CNN. Okay, so this is a different neural network architecture. In summary, the operation extracts crops from the input image tensor and resizes them. What all can we do? Okay, so let's keep neural networks aside for a second. What about linear? Fuck, what was that called? What was that called, dude? What was that called? It was linear something. Machine learning, linear, regression. That's what. Man, I think I need to sleep because like I'm blanking on my words. Linear regression. Okay, so I'm not seeing anything. What exactly does this library allow you to do? So I'm gonna or could it be that this library provides you with the tools to build those concepts? I need to look into that. So at this point, I'm not really sure if DirectML would be more comparable to... Fuck, we were supposed to be doing fucking Rust studies, but now we are looking into this. But also, this is a very good example of how the Win32 API has so much stuff to explore. So much. There's a crazy amount of stuff that you can explore here. And I intend on exploring some of these things. Some of my areas of interest here are the UI, first of all, then graphics and gaming. I want to look into the DirectX 12 side of things. Also DirectX 11. Audio and video. I definitely want to. I mean, keep video aside. I want to look at the audio side of things as well. and I think devices as well to a certain extent. I probably won't be touching a bunch of the other things. At least I don't think so. But like already these topics that are mentioned here, this is already like way too much for me to look into. Um, Besides, if I'm trying to learn the Win32 API, I shouldn't be trying to learn every fucking thing. I should like pick a specific thing, a specific topic, and then like study it properly. So yeah, for me, I have these four topics. So what is data access and storage? Okay, so it's more than just file access. There's a lot more there. So I'm not really looking to get into that. But to give you an example of what I was talking about with the Windows messages and queues, it's great because like they have dedicated sections that explain all of this stuff to you. This is the API, right? There was. Hold on a second. For programming guidance for this technology, see this. Okay, so what are we looking at here? How did I get to this? Desktop user interface, okay. Desktop technologies, Win32. Okay. The fuck? Oh, okay. So I was in, I think, API reference by header, maybe. I think I was in API reference by header. Programming reference for this. Was it? Oh, yeah. This is API reference by header. Where is it explaining it here? I think it's here. Yeah. So here, for example, if I click on desktop app user interface, it goes into detail with like a lot of the topics that are going to be helpful for you. Just a second, I need to move my VTubing avatar to, I think the bottom left should be fine. Just a second. I'm trying to get a good angle here. Uh yeah, I think this is good. All right, perfect. So, this is a good example. Like this thing teaches you about how all of these concepts work. Maybe I should zoom in. So, for example, messages and message queues, it has a whole thing that explains everything about how messages work, the different types of messages, and how messages are handled, how you can send and receive messages. Um, there's a whole bunch of stuff here that you can read. It's great. It's amazing. Like if somebody wants to study the Win32 API, there's a whole bunch of stuff that you can learn. They have the docs available there. That being said, I need to look into direct ML. Like exactly what does direct ML? Hold on. Um. Okay. So this is the DirectML repo. DirectML is a high performance hardware accelerated. Just a second. Okay. Direct. Wait, this uses PyTorch. Okay. We'll carry on reading. Uh, should I just read this instead? Yeah. I was reading the top right, but like now I figured I'd read the README instead. Hold on. There's an introduction to DirectML here. Let's take a look at that. Yeah, I should probably be looking at this. Direct ML, direct machine learning, is a low level API for machine learning. Hardware accelerated machine learning primitives called operators are the building blocks of direct ML. For those building blocks, you can develop such machine learning techniques as upscaling, anti-aliasing, and style transfer, to name but a few. Denoising and super resolution, for example, allow allow you to achieve impressive ray traced effects with fewer rays per pixel. Oh, okay. So the idea here is that you implement the blocks, and then with the blocks you build a bunch of the more high level stuff. I'm not looking to do that. As great as that is, that's amazing. Um, if it's just that if I start doing that, then I'm gonna lose a lot of time. For the time being, I'm trying to learn how to do the higher level stuff rather than trying to implement the lower level stuff that makes the higher level stuff achievable. Because like even when I'm trying to implement the higher level stuff, that's also going to take me some time. So like I realized this a while back when I was trying to learn machine learning, because like I've always had this problem where I if I'm learning something, I need to learn how things work on the lower level, right? Because I mean I'm saying right as if it's like a universally known fact, but like no, I need to know how things work on a lower level. I need to understand how whatever it is that I'm learning works. And unless I learn how it works on the lower level, I'm not going to understand how it works. It's just my curiosity is always like, okay, why is this working this way? Why is that working that way? How exactly is this thing working in the back end? Stuff like that. So I always have this curiosity, and to properly understand how certain things are working, I need to implement them myself to a certain extent. And that doesn't always work out best for me. I get to learn a lot by doing that, but I also waste a lot of time. In the end, I do get to learn a lot, but like if I didn't try to do that, I would be making so much more progress. And I made that mistake with ML. Um, I was trying to implement the lower level stuff so I could then implement the higher level stuff. The problem was I didn't fully understand the higher level stuff that I was trying to implement. So like I would then kind of go back and forth between them. Cause like when you're learning ML, there's already the high level concepts that you need to learn and understand. But to then try to learn the low level concepts that make those high level concepts possible, that kind of complicates things. It's great if you do that. It's very helpful. You get to learn if you do that. But like with with ML, I kind of had to like let the low level thing go for a little bit and not try to implement every fucking thing myself. Instead, I decided, okay, I'll just do the higher level stuff so that I can get a hang of the various ML and deep learning concepts. Um, that is why I've been making a lot more progress now than before. So like I'm gonna try and build a neural network, but I'm gonna be using a library that builds like it's still gonna be a little bit there's that complication of actually building and understanding how the neural network works, but I'm not going to be building the underlying technology that makes building the neural network possible. I'm going to be using a pre-made technology that helps me build the neural network. I still have the added complexity of having to understand how the neural network works, and that's why I'm not trying to add more load onto myself by trying to do the low level stuff along with the high level stuff. So, for example, I'm going to use PyTorch to implement, or TensorFlow as well. I'm going for PyTorch for now, but like depending on what examples I'm looking at, I can like switch between the two. I'm going to use PyTorch to implement a neural network. But then even there, I have a bunch of things to understand. Like within neural networks, even if you're building a very basic neural network, how the fuck did we get here from fucking Rust, dude? Holy shit. Okay, anyways, I'm gonna finish what I was saying. Even if you're building a very basic neural network, there's a lot to understand. For example, um, how do I where do I start? Like, there's a lot of concepts. You have the concept of a perceptron, how the perceptron is working. A perceptron is like one node of the neural network, one node of one of the layers in a neural network. That's called a perceptron. Then there's the concept of activation functions. Then there's the process through which you create weights, which is the training process, the various steps that you have to take throughout the training process, steps that you have to take to minimize loss, minimize error. That also has a certain level of math involved in it. The activation function has a certain level of math involved. I need to experiment with various activation functions. I need to various. I need to experiment with not using an activation function and like seeing what happens if I don't use an activation function. This is what I'm talking about. Like there's so much stuff to explore on the higher level itself that it's not a good idea for me to go down to the lower level, because otherwise I'm it's just gonna get too complicated for me, and I'm gonna end up like pushing it aside and going and doing something else. So if I want to make progress with this, then I need to learn the high level stuff first, and then if need be, I can learn the low level stuff. Okay. You can integrate machine learning. You can integrate machine learning inference workloads into your game engine, middleware, backend, or other application. DirectML has a familiar. So okay, I don't think this was comparable to PyTorch or TensorFlow, because like this provides you with the tools to build those kinds of tools, or this provides you with the tools um to build like slightly higher level concepts and then like build your way up from there. But like those frameworks, they provide you with already very high level concepts. You can still implement your own if you want, but they provide you with the high level concepts, the high level tools already. But this is great because like if you want to implement a custom solution of your own, this gives you that ability. That being said, I'm probably not going to be looking into this. What I am going to look into is uh what is this? This is the API, right? Okay, I'm looking for. Okay, let's go back. I'm looking for by feature, and in feature. Wait, why does it look like this? Okay, yeah. So what am I looking at here? Wait, am I looking at the right thing? I'm not sure if I'm looking at the right thing. User input and messaging. Why does this look like this? What am I looking at here? Wasn't there a different thing that we had seen earlier? I think it was here. Oh, it was here. Yeah, I was looking at the wrong thing. So here, a couple of things that I want to look into is desktop app user interface, and audio and video, and devices, and there's probably going to be a couple of other things. Oh, graphics and gaming. Yeah, that's another one. You know what? Let's look into it just real quick glance. I don't know if it's going to be. I don't know if it's going to be quick. Getting started with I don't think I'm going to be going too deep into this either, because this involves a bunch of setup. And to be honest, like, it's not what I'm trying to do. Like, I'm not trying to do low level graphics stuff, at least not right now. For the time being, if I'm just trying to do stuff with the Win32 API in Rust, I would probably focus on. I'm really interested in looking at the audio side of things, because I want to see to what extent we can do audio related stuff. Because, like, the way I see it, if we are interfacing with the Win32 API, we are going pretty low level, right? I don't know how low level exactly, but like we are going pretty low level. Though also like, there are multiple levels. It's worth mentioning that there are multiple levels even in this. So a good example would be, I think input is a good example. Where was input? I think input comes under user interface, doesn't it? Or is there a messaging thing separate? Is that like a separate topic? Uh, Desktop environment. Okay. Nope. It's not that. Could it be under devices? I'm not sure if it'll be under devices. Yeah, I don't think it's under devices. I think it was under this. I think it was under this. Hold on. Let's explore this. What happened? All right. User interaction, I think. Yeah, there it is. So here, this gives you various options to mess around with user input. And even here you have like high level and low level stuff. Audio is actually a very good example. Audio and video, media related stuff is a very good example of how they give you high level and low level options. Like, you don't have to go completely low level. They do give you a slightly higher level option. But if you want like very fine control, then they give you a low level option as well. I probably should have gone to audio directly. Yeah. So stuff like this. So core audio APIs is a low level API for audio capture and audio rendering, which can be used to achieve minimum latency or to implement features that might not be entirely supported by high level media APIs. Now, which one of these was the high level one? I think a couple of them were high level. There were some options here, because like each of them does something different. Each of them has like a different set of features, and some of them, they're like older ones, some of them are newer ones. You can like pick and choose which one you want. But yeah, my point is, there's a lot for me to explore in. um I'm just noticing what this looks like on stream, like when I'm scrolling. Why does this look so bad? Hold on, let me. Oh, it doesn't look bad. It just looks bad because my video player is small. It doesn't look bad. Okay. I keep forgetting that, because my video player is actually tiny. Like, when I'm looking at it in the stream manager, it's pretty small. I've kept it that way on purpose, because the whole idea is for me to be able to just see my stream, just to make sure that the stream is still running. I'm not trying to actually watch my own stream, so it doesn't matter if the screen is like super small. But like, because the screen is super small, so it's sometimes you see like artifacting. I guess that's the best way to put it. Okay. So narrowing it down, I would, if I had to pick two topics, it would be user interface, one, and audio and video, two. If I had the time to add a third one to mess around with, it would be devices. Just just learning about how I can enumerate devices that are connected to the system and how I can maybe fake a device as well. Though it's, I feel like to a certain extent that gets a little bit complicated. You know what I'm waiting for? Or well, I mean, not really waiting for it, but like I kind of wish every now and then when I get the thought about it, then I kind of wish it becomes a thing in the future. Doing driver development with Rust, because like right now it's limited to C, maybe C++. I think mainly C, and they have like ample documentation for it. Okay, from a driver programmer's point of view, because like I haven't made Windows drivers, I don't know if people who do make Windows drivers would agree when I say that there's ample documentation. But there's a lot of documentation. Is it enough documentation? I don't know. But there's a lot of documentation that gives you a lot of information if you are new to driver development and you're trying to learn how to make drivers for Windows. There are even like situations where they explain to you that you don't always have to make a custom driver for every single thing. There are certain like certain structures, certain concepts that you can, certain tools that are available to you that you can use. So you may not necessarily need to implement your own driver from scratch. But yeah, I'm waiting for driver development to be possible in Rust. In the meantime, I'm not in a rush for that because like I still have to explore the fucking Win32 API. But yeah, that's a very good use case for me when it comes to like doing stuff in Rust. Just exploring the Win32 API. You know what? Yeah, because like I always say this, like if you want to learn how to, dude, I think I missed my recent hydration break. I don't know. But yeah, okay. What I always say is like if you are trying to learn, if you are trying to learn a new language, like a new programming language or a new tool of some sort, a new game engine, a new 3D art program or whatever it is, if you're trying to learn how to use a set of tools better and you're trying to get better at using them, make dumb shit. Like make just make things. Whatever it may be, no matter how silly the thing may be, just work on things. Keep building things. Because everything that you build, no matter how silly, no matter how small it may be, every single project that you work on, it's going to teach you something. You're going to learn something from it. Because I mean, that's been my experience so far. Every project that I've worked on, whether it was a bigger project or a smaller project, even the smallest projects, even shitpost kind of projects, like just silly projects that I was working on just for fun, even they taught me something. So like I think I'm gonna explore the Win32 API through Rust, and in doing so, I'm gonna learn about the Win32 API, and I'm also gonna get better at Rust, get more comfortable with Rust, because I'm gonna get to explore various Rust related concepts. Um, yeah, dude, I'm excited. Okay. We should close this. This has been quite the detour. It was a fucking detour of a detour. Holy shit. Give me a second. It's close to hydration time, so I'm gonna hydrate and then we're gonna carry on reading. Okay, so back to this thing. So the first path is an absolute path, which can be either the crate name or just the word crate if whatever you're trying to access is already within the current crate. Then is a relative path. A relative path starts from the current module and uses self, super, or an identifier in the current module. Okay. Wait, it uses self, super, or an identifier in the current module. Okay. All right. I'll keep that in mind. Both absolute and relative paths are followed by one or more identifiers separated by double colons. All right. Returning to the previous example, say we want to call add to waitlist function, call the add to waitlist function. This is the same as asking what's the path of the add to waitlist function. Okay, listing so and so contains listing so and so with some of the modules and functions removed. We'll show two ways to call the add to waitlist function from a new function, eat at restaurant, defined in the crate root. These paths are correct, but there's another problem remaining that will prevent this example from compiling as is. We'll explain why in a bit. Oh shit. I accidentally hit the left key. Where were we? Here, I think. We show two ways. Okay, these parts are correct. Okay, we'll explain why in a bit. All right. Eat at restaurant. The eat at restaurant function is part of our library crates public API. Okay, that's a public function. All right. So we mark it with the pub keyword. In the exposing parts with the pub keyword section, we'll go into more detail about pub. All right, cool. All right, let's try this. Let's go into this module. Let's create a method, eat at restaurant. Okay. And then here we use an absolute path and a relative path. Oh, hold on. Wait. Yeah, I forgot. This is an old habit. Cause like this is an old habit from like C sharp, where the program it absolutely has to be within a namespace and a class and then a method. So like you have namespaces have classes, or I think they can also contain more namespaces, but like for the sake of simplicity, namespaces have classes have methods, and like within the methods you do stuff, right? Even like with even with like the latest or not latest, but like a fairly recent addition of like top level statements, even that implicitly the compiler is doing that work for you. Like it's creating the class and namespace and like method and all of that stuff. So yeah, this is an old habit, but like usually with Rust programs you can directly start something like this. You don't absolutely need a class. I don't know if implicitly it's doing something or if Rust's thing is just like it's a whole like it just has like a different way of working. So like you can just define functions and call them. You don't absolutely need a class or a crate, which technically it is still like within something. It is still within some kind of container, which in this case is a crate. I'm trying to remember that what we studied yesterday, how the hierarchy went. So you have packages. Packages have crates. Crates have modules. Now, do can crates also have functions directly? Because like I have seen that. I don't think I need to ask that question because I have seen that. Um, a bare bones hello world binary crate, it's gonna contain a main function. It's not gonna contain a module unless you decide to create one. Okay, so here we can have a relative path. No, we can have an absolute path, which is crate, uh, front of house, add to waitlist. Why did that happen? Oh, I have to use dot. Do I have to use dot? I don't think I have to use dot. I have to use this, right? Oh, it's not accessible. Hold up. Oh, is this what they were talking about? Like the Zeus. Hello, hello. It's been a while. How are you doing? Welcome to the stream. How's it going? We are learning some Rust. We are studying. I recently had another distraction where I was like, okay, I need to go back to learning Rust and specifically learning about modules and learning about traits. We haven't gotten to traits just yet, but like we are learning quite a bit about modules. Um, but yeah, hope you are doing well. So okay, okay, so as soon as I tried to access the function here, I realized why they were saying that there's going to be an error. The error is because this is not a public function. The function over here, I mean, this thing, if I save it, it should give an error. Give it a second. It's doing the cargo thing here. Yes, it has. Yes, it has been. Doing all right. How about yourself? I'm okay. I'm okay. I've been doing a lot more study streams. I've been learning a lot, quite a lot. Recently, I got into Godot, and holy shit, I've been enjoying learning a new game engine a lot, like big time. And there's so many things that I can do with the game engine as well. Cause like it's not like, especially when it comes to like in terms of experimenting, which I do a whole lot. There's so much that I can do with Godot. Um, it's really powerful in many aspects. One of them being that it has this technology called GD extension, which allows you to basically create language bindings for any other language, any other programming language. And um, there's already three or four, I think, in development. The most commonly used ones, from what I've seen, are well, C Sharp is the officially supported one right now. GD Script is their own like in-house developed language. Well, I mean, there's no house there. It's an open source project. It's their own like GD Script is the preferred programming language. Even they highly recommend using GD Script. But like if programmers want to use a different language, they have other options. C Sharp is officially supported by Godot, by the development team, and they're slowly moving it into GD extension. So even C Sharp is then going to use GD extension to call into the various engine API methods. But other than that, you also have Python support. You also have Rust support, and I think to a certain extent you have C++ support. I don't remember, but like C Sharp, Python, and Rust are like three of the languages that are like of huge interest to me. Um, Rust is something that I'm currently learning. C Sharp and Python, I've been doing them for year close to it. Well, C Sharp I've been doing for more than a decade. Python close to a decade. So like this is great. There's so many things. I want to do like Python ML stuff in Godot. I want to do a bunch of Rust related things in Godot. And I also want to test out C sharp stuff in Godot, mainly just for testing out C sharp stuff. Um, but yeah, yeah. Okay, okay. That that little tangent aside, let let's carry on reading this. I'm guessing. So okay, this was an example of absolute path, which I know why exactly it's not working. They did mention earlier here that um, we show two ways to call add to waitlist function from a new function. These paths are correct, but there's another problem remaining that will prevent this example from compiling. I'm guessing it's this. I'm guessing this is the problem. It's the pub keyword, the fact that it's not a public function, and then relative path is using directly accessing. So like the module is within this file already, right? So we have front of house. Okay, so we have front of house, and then what can that access? There is, oh, that cannot access anything because, well, none of the other modules inside are public. So that's another issue. So hosting is, it's not, it's not public. And then add to waitlist is also, again, not public. So this should also, yeah, there, it's throwing an error because they're both private modules. So here's what I can do. I If I make this public, that should fix one issue. And then if I make this public as well, that should fix the other two issues. No, hold on. There's an issue here. Oh, wait. Oh, yeah, I missed hosting. There would anyways have been an error there. Yeah, yeah. There would still have been an error here if I, let me just, yeah, yeah. There it is. Okay, cool. So let's see if that's what they were talking about. The first time we call the add to waitlist function in eat at restaurant, we use an absolute path. The add to waitlist function is defined in the same crate as eat at restaurant, which means we can use the crate keyword to start an absolute path. We then include each of the successive modules until we make our way to add to waitlist. We can imagine a file system with the same structure. We'd specify the path and run the add to waitlist program. Using the crate name to start from the crate root is like using slash to start from your file system root in your shell. Okay. The second time we call add to waitlist in eat at restaurant, we use a relative path. The path starts with front of house, the name of the module defined at the same level of the module tree as eat at restaurant. Okay, here the file system equivalent would be using the path so and so, so and so, so and so. Okay, starting with the module name means the path is relative. Okay. Choosing whether to use a relative or absolute path is a decision you'll make based on your project and depends on whether you're more likely to move item definition code separately from or together with the code that uses the item. For example, if we move front of house module, oh, just a second, hydration break. Okay. Where was I? For example, if we move front of house module and the eat at restaurant function into a module named customer experience, we need to update the absolute path to add absolute path to, okay, yeah, we would need to update the absolute path. That makes sense. That makes sense. Because like if we were, if this said crate, well, if this said crate dot so and we moved this elsewhere, then the path would kind of change, right? Okay, but like, how would that work if it was relative? Because like, if it's relative and we move it into, okay, let's carry on reading. Let's see what they say about relative. We need to update the absolute path, but the relative path would still be valid. However, if we moved eat at restaurant function separately into a module named dining, the absolute path to the add to waitlist call would stay the same. Okay, but the relative path would need to be updated. How would that wait, we need to update the absolute path, but the relative path would still be valid. The relative path. Okay, so I didn't get how, because like if we, what they're saying here is we are moving and the eat at restaurant function into a module named so and so. If we moved the front of house module and the eat at restaurant, what happens to hosting then? Okay, let's try um, customer experience, and let's bring this down here, I guess. So what does that change here? It broke both of them. If we move the front of house module and the eat at restaurant function into a module named so and so, we need to update the absolute path to add to add to waitlist. That makes sense, but the relative path would still be valid. Is that's not being demonstrated here? Because like over here now, I need to update the relative path to include this. I probably also need this keyword. What if I tried this? Yeah, no, that doesn't work. I need to access it properly. Because like in both, so then in both cases it needs to be updated, right? Maybe it's just because I haven't slept yet, so like I I'm not able to imagine. Yeah, maybe I just need some examples. I need to implement some examples myself. I don't think I need to worry about this too much. In the future, as I work on more things, I'll find I'll find I'll be able to figure out the advantages and disadvantages of each approach. That's the word I'm looking for. Okay. Our preference in general is to specify absolute paths because it's more likely we'll want to move code definitions and item calls independently of each other. All right. Let's try to compile so and so and find out why it won't compile yet. The error we get is this is private, hosting is defined here, and hosting is private, and so and so. Okay, that's the error. Okay, so I guessed right earlier when I'd mentioned that. Let's just change this back. Okay. Yeah, so I'd guessed right when I'd said that, yeah, that was the error. It's the fact that it wasn't public. The error message says that module hosting is private. In other words, we have the correct paths for the hosting module and the add to waitlist function, but Rust won't let us use them because it doesn't have access to the private sections. In Rust, all items, functions, methods, structs, enums, modules, and constants are private to parent modules by default. If you want to make them, if you want to make an item like a function or struct private, you put it in a module. Okay, cool. Wait, it's been a while. Is the music still going? No, I think the music got paused by YouTube. There it is. Okay, let's. All right, great. By the way, speaking of music, shout out to Machine Supremacy. I've been playing their music. Go check them out. They make some pretty awesome music, especially if you're into video game inspired music. They've made some amazing. They made a lot of amazing songs. Okay, where was I? Okay, items in a parent module can't use the private items inside child modules. Items in a parent module can't use private items inside child modules. Oh, okay, all right. But items inside child modules can use the items in their ancestor modules. That makes sense. Yeah, that makes sense. This is because the child modules wrap and hide their implementation details, but the child modules can see the context in which they're defined. Okay. To continue with our metaphor, think of the privacy rules as being like the back office of a restaurant. What goes on in there is private to the restaurant's customers. It's, yeah, okay, it's private to the restaurant's customers. But office managers can see and do everything in the restaurant they operate. Okay. Rust chose to have the module system function this way so that hiding inner implementation details is the default. That way, you know which parts of the inner code you can change without breaking outer code. Which parts of the inner code you can change without breaking outer code. Okay, I'm trying to imagine that. Yeah, maybe I'll need to implement something myself in order to actually see that in action. Okay. However, Rust does give you an option to expose inner parts of the child module's code to outer ancestor modules by using the pub keyword to make an item public. All right. Okay, exposing paths using the pub keyword. Let's return to the error that told us the hosting module is private. We want the eat at restaurant function in the parent module to have access to the add to waitlist function in the child module. So we mark the hosting module with the pub keyword. Okay, all that is good. Unfortunately, the code is still giving an error. Yeah, probably because, wait, what did you add the pub keyword to? You added it to hosting, but you didn't add it to waitlist. So that's probably the next issue. Yeah. So the function itself, the module is public, but the function is not yet public. What happened? Adding the pub keyword in front of mod hosting makes the module public. With this change, if we can access front of house, we can access hosting, but the contents of hosting are still private, making the module public. Oh, okay. So I'm kind of starting to see. I'm kind of starting to see what they're talking about here. So if we look at this code, if we look at this code here, this line, either one of these lines for that matter, we are accessing the front of house module. Within that, we are then accessing the hosting module. And within that, we are then accessing the add to waitlist function. But if the add to waitlist function is not visible to the ancestor modules, so like in this case, not the, yeah, if it is not accessible to the parent module, or would it be the grandparent module in this case? I'm not sure. But yeah, the if add to waitlist is not accessible to front of house, the front of house module, then you can't really call it using this path, right? That makes sense. But the contents of hosting are still private. Making the module public doesn't make its contents public. The pub keyword on a module only lets code in its ancestor modules refer to it, not access its inner code. Because modules are containers, there's not much we can do by only making the module public. We need to go further and choose to make one or more of the items within the module public as well. The errors in so-and-so say that add to waitlist function is private. The privacy rules apply to structs, enums, functions, and methods, as well as modules. Let's add so-and-so. Okay, so at this point, they're going to add the pub keyword. Now the code will compile. Let's wait. What's the command they're using to compile the code? I think it was test, wasn't it? Did they mention the code somewhere here? Oh, okay, good. They're gonna explain super as well now. Okay. To see why adding the pub keyword lets us use these paths in add to waitlist with respect to the privacy rules, let's look at the absolute path and the relative path. In the absolute path, we start with crate, the root of our crate. I like how they're dissecting like these lines of code. That's actually really helpful, especially for someone who's learning about modules for the first time, and like it helps them visualize it. The root of our crates module tree. The front of house module is defined in the crate root, while front of house isn't public because the eat at restaurant function is defined in the same module as front of house. Oh, is that how it would be said? Eat at restaurant and front of house are siblings. That while front of house isn't public, because eat at restaurant function is defined in the same module as front of house. Oh, it's defined in the root crate. That's what they're talking about. We can refer to front of house from eat at restaurant. Also, wait, does it? Yeah, okay. Okay, anyways. Next is the hosting module marked with public. Oh, hydration break. Give me a second. Okay, where were we? Next is the hosting module marked with pub. We can access the parent module of hosting, so we can access hosting. Finally, the add to waitlist function is marked pub, and we can access its parent module, so the function call works. Okay. In the relative path, the logic is the same as the absolute path except for the first step. Rather than starting from the create root, the path starts from front of house. The front of house module is defined within the same module as eat at restaurant. Okay. So the relative path from the module in which eat at restaurant is defined works. Oh shit, I didn't realize that was gonna be an ad. Well, I've already taken a hydration break, so I guess I'm gonna wait for like 20 seconds. Alright, welcome back. So, carrying on, if you plan on sharing your library crate so other projects can use your code, your public API is your contract with users of your crate that determines how they can interact with your code. There are many considerations around managing changes to your public API to make it easier for people to depend on your crate. Okay, these considerations are out of the scope of this book. If you're interested in this topic, see Rust API guidelines. Okay, best practices. Okay. All right, look, I'm gonna carry on reading this later on, but I'm getting like super tired. I've been tired for like the past 15 minutes or half an hour. And I'm just gonna keep getting more and more tired. So I'm gonna relax for some time and carry on reading this, but I'm gonna end the stream here. Zeus, thanks for hanging out. Thanks for stopping by. And anyone else who might have been lurking in the chat, thanks for hanging out. I hope you guys have a nice day, and I will see you all next time. Peace.